Before I got married, I dated a banker. Okay? But I didn't want to date her anymore after a while because I lost interest. Okay. All right. So that was my joke. That was what? You're wrecking my lecture here. It's a triangle, and we already learned that in a triangle, the sum of the angles is how much? 180. So you might want to make a little table that kind of looks like this, kind of. And sides and sum. So for a triangle, I'm going to hide this thing. There are 3 sides, and the sum, that's a sum. And we already realized or learned that that's 180 degrees. Okay? Right. So then some of you already know that if I have a quadrilateral, maybe you know this, maybe you don't know this, but if I were to draw a quadrilateral, any old quadrilateral, not just a rectangle or something like that, that looks kind of like a quadrilateral. You might know, I'm recording again, guys. And so if I have 4 sides, oh look, I made a little straight line there. McConnell, do I have to kick you out of class?
No, Mr. Leader.
So, let's continue before we're so rudely interrupted. Does anyone know what the sum of this angle plus this angle plus this angle plus this angle would be? Devin knows. 360 degrees. Does anyone know why it's 360 degrees? Very good, Natalie. So what Natalie said, and she's correct, that if I were to cut this up, how many triangles would I have? 2 triangles, and each one has 180 degrees in it, right? 180 degrees and 180 degrees. So that's why the sum of the angles of a quadrilateral, that's called a quadrilateral, has 180 degrees. And then if we take it a step further, right, with a 1, 2, 3, 4, 5-sided figure. Come on, buddy. It's not changing. It was supposed to change, but it didn't. That's okay. So this is a pentagon. Let's pretend that this is a pentagon. I intentionally don't want it to be a regular pentagon. Yes, Sam? 540, because I could, if I were to draw triangles from one vertex in here, I could divide it up into 3 triangles. Do you see that? And so here I have 180 degrees, and here I have 180, and here I have 180. So 3 times 180 is 540 degrees. Yeah? Okay? And if I went one step further, let's go one step further. Let's draw a nice hexagon. Where's a nice hexagon? Hexagon. Oh, I could have used that pentagon. Here's a is that a hexagon? 1, 2, 3, 4, 5, 6. I could divide that into 1 triangle, 2 triangle, 3 triangle, 4 triangles, right? And altogether I get 4 times 180, right? 180, 180, 180, 180, which adds up to 720. So that is 6 sides. Sum is 720 degrees. So if I have n sides, who can think of a formula that would give me the number of degrees, the sum of the number of degrees? N sides. N sides. How How many so if I have 4 sides, I have how many triangles? 2. Okay? So if I have 5 sides, I have 3. 6 sides, I have 4. N sides, I have N. How many triangles would I have? N minus 2. Very nice, okay? So that formula would turn into, I have to erase this or I'll run it, N minus 2 times 180 degrees, okay? And so that's your first conjecture on your sheet, I think, isn't it? Oh no. Polygon sum conjecture, C32. It should say the sum of the measures of the n interior angles of an n-gon is n minus 2 times 180. So that's what you put in there. N minus 2 times 180. And the conjecture sheet is on my website if you need it, but it's there. Okay? And before that, you had 2 previous conjectures. C30, the sum of measures of 4 angles in any quadrilateral is 360, goes in that one. Or I could bring these up somewhere. Where could I bring these up? There we go. For you viewers at home, we're going to bring this up right here. Chapter 5 we're in. Here's the conjectures. Open. Okay. So if I were to write it up, I know how to fix that. Okay, I have to go. There's something called annotate over desktop. I'm learning. Okay? And so right in here, this should be 360 degrees, right? And this should be 540 degrees. And then more generally, this should be n minus 2 times 180 degrees. And that's all the conjectures you need to know for today. But I'm going to do a couple example problems that we're going to look at. I'm not telling you the homework yet. Just chill. Okay? So let's do another example problem. Save this page. Yeah. Alright, so I'm going to take my tool and draw another quadrilateral. And, oh, this isn't going to work, is it? Let's see what happens if it makes a quadrilateral. Come on, make something. It didn't like that quadrilateral. Let's try again. There, except it looks like a square, but that's okay. So let's first pretend that this is not a square, and this is a 90-degree angle. And I don't know what this angle is, but I'm going to put a little mark on here and a mark on here. Okay? And I know that this angle is 70 degrees, and they say find A and C. Could you do that? Could you do that? How many degrees do I have altogether? 360, and then what? Subtract 70, right? So how much does that give you? 360?
290.
Oh, I have to minus 92, right? So that makes 200 degrees. So that equals 200 degrees. And what do I do with that 200 degrees? Divide by 2, and so I get 100 degrees. Now more algebraically, what I might want to do is call this x and this x, and then I could write a little equation, 2x plus 70 plus 90 equals what? 360. Okay, so I don't require that you write an equation, at least at this point. So that's how that would look. Alright? So maybe you have a problem that's a little more complicated, like this one. I'm going to have to draw a hexagon. I have a regular hexagon tool here. Where's my regular hexagon? I just used it, didn't I? Okay? So here's a hexagon, but off of this hexagon, I'm going to have some things coming off of the hexagon like this. Let's pretend that these are perfectly straight. So your picture looks kind of like this, and these are straight lines, let's just pretend, and I give you this angle, this is a regular hexagon, which means all the angles and all the sides are the same, and then that's the only thing I give you, and then I say find angle X over here, find the measure of X. Could you do that?
I don't know.
God? How would I do that?
Well,
Go ahead.
I know how to do the first part. Like, you would divide 725.
Nice.
6.
Okay? So the sum of this part, right, is going to be n minus 2 times 180. Okay, in this case, n is 6. And so Makana said correctly that it's 720 degrees. But then what do I do? Divide it by 6. So each one of those angles would have to be 120 degrees, right? And then since I know this is 120 and this is 120, what does each one of these guys right here have to be? 60. 60. And what type of triangle do you have here? Equilateral. So what would that have to be? 60. And that's how you do something like that. See? Okay? So that's kind of a good little problem. And I really, and then I just have one word problem for you, and then we'll be done. Here, I don't want that kind of paper. I want regular paper. I don't like red anyway. It makes me weird. How many sides does... So, how many... What happened? How many sides does a polygon have? So sometimes I'll go backwards. Polygon have whose with an angle sum, an interior, you call the inside, we'll talk about exterior angles next time. An interior angle sum of 1800 degrees. Ooh, that's hot. 1800 degrees. Okay? So in that case, what you do is use the sum formula, and you say that n minus 2 times 180 equals 1800. You understand that? Okay? And then what could I do? What's nice and easy to do in this case? How can I get rid of this? Yeah, you could distribute and then solve it that way, but it's easier since this goes into this nicely, right? Divide both sides by 180, and in that case that goes away, and I get n minus 2 is equal to what? 10. And so it is? Add 2, and I get that n equals 12. So it has 12 sides. Alright? Your homework, which I'm going to tell you now, is, that's about it. Okay? Page 257, 1 through 11. And then 12 through 20 even. It's not that bad. Okay? And I'm gonna be done. And goodbye. Look, that